Okay, so we're going to learn how to write formulas for ionic compounds. The slide says, review the elements that form ions with a predictable charge. Okay, so we've got metals that are in group 1A, 2A, and 3A, and we will also learn about zinc and silver in a few minutes. Those metals form ions with predictable charges. It's related to the group number. Group 1 forms +1 ions. Group 2 forms +2 ions. Group 3 forms +3 ions. Okay, 3A, not the numbering on these periodic tables. Also, we have the nonmetal ions. There were two ways we could remember how to predict their charges. One was pretending the periodic table was a board game. And you're starting at the far right corner, right side at the noble gases, column 8A. That's 0. The noble gases are like the nobles of Europe, the kings and the queens and the dukes and the duchesses, and they don't associate with anybody because they're self-sufficient. They don't need us. So they don't interact. They don't form compounds. So they're zeros. They don't form charged ions at all. And so then we count backwards. So fluorine is -1, oxygen's -2, nitrogen is -3. And that's how we predict the charges of the nonmetals. Or you can think of the group number -8, whichever one works for you. You'll get the same answer. So those are the ions that form, the elements that form ions with predictable charges. And then it's important to know that ionic compounds always have positive and negative ions. I've mentioned that a couple of times. You have to have opposites in order for them to attract. And then when we write the chemical formula, the sum of the positive charges is always going to equal the sum of the negative charges. They are going to combine in a way that the overall compound is neutral. Nature abhors a vacuum, and nature also doesn't like charges to be separated from each other, which is partly why opposites attract. That's just it's an energy thing. There's lots of fancy explanations for it, but nature doesn't like it when you separate charges, and they'll tend to go back together. And so those ions are going to react and combine in a way that the charges are going to balance and add up to 0. So those are important ideas to remember. So here are the instructions for writing ionic formulas. Write the symbol for both ions, including the charges. Now later on, when you get good at this, I'll let you skip that part, but for now, you really, really have to write the formulas for both ions with their charges. The charges are going to tell us how to put them together. Now, these are the instructions your book gives, and I'm going to give you a slight modification. Make the magnitude of the charge on each ion, without the sign, become the subscript for the other one. Okay, we tend to call this the Crisscross Method, and I'll show you how that works in a minute. And then, if possible, reduce the subscripts to give a ratio with the smallest whole numbers. So we'll see how that works in a minute. Personally, I prefer to look at the charges. If you have +2 and -2, all you have to do is push those two ions together, and their charges will add up to 0. If you have +1 and -3, then you've got some work to do, and that's when you do the crisscross thing. And then at the end, check to make sure that the sum of the charges of the cations exactly cancels the sum of the charges of the anions. So those are the instructions. Let's look at how this works. Write a formula for the ionic compound that forms from aluminum and oxygen. First thing is write the formulas for the ions with their charges. So aluminum. Aluminum is in group 3A, and so we know that its charge is 3+ from the periodic table. Oxygen is in group 6A. 6 minus 8 is -2, or we count backwards, count to the left 2 places, and we end up with -2. And we look at those charges. +3 -2. They're not the same. They don't add up to 0. So most students like this crisscross method, and so that's fine. It works about 95% of the time. So here we've got the 3. That becomes the subscript on the other ion. And the oxygen has a 2 charge, and that becomes the subscript on the aluminum. And there we have our formula, Al2O3. So how is that working? Well, if you're a math type person, what we're doing is we're looking for least common multiples. The least common multiple between 3 and 2 is 6, and so we're going to multiply aluminum with a 3 plus charge by 2 to get 6, and we're going to multiply oxygen with its 2 minus charge by 3 to get 6, and we'll end up with plus 6 minus 6 adds up to 0. If that makes sense to you, you don't need any more explanation on that. If it doesn't make sense, then let's go with this other explanation here. So let's draw pictures. Pictures can be very helpful. So here we have aluminum 3 plus, and we have O 2 minus. And down here, I'm just going to keep track of the total positive and negative charge. So if I have one of each, I've got a total of plus 3 and minus 2. Those are not the same. They don't add up to 0. I need them to add up to 0. So I need more negatives because I've got too many positives. I've got plus 3. I need to put in some more negatives. I can't put in half of an oxygen ion. I can't put in an oxygen ion with a 1 minus charge. All I can do is add more of either ion. So I'm going to add another oxide ion. Put that in there. And that'll bring my negative total to minus 4. And it's like, well, that's great. Now you're messed up the other way. Well, we'll just keep going and see what happens. So I've got plus 3 minus 4. Now I need more pluses. So I'm going to put another aluminum in, giving me plus 6 over here. It's still messed up. Keep going. Let's put in another oxygen over here. Oh, there we go. You see how that worked? Eventually, you can come to the point where they balance out. So we've got two aluminums here, and that's why we have Al2. There's 3 oxygens, and so we have O3. So Al2O3. If you take the number of ions, the number of aluminum ions times the charge on each has to be the same as the number of oxide ions times the charge on that. One's positive, one's negative. They add up to 0. Any questions? Yes?
Does the crisscross thing always work if we understand the crisscross?
The crisscross thing always works provided that you check and make sure that you don't have like, Mg2, no, it wouldn't be Mg, it's Na2Cl2 or something crazy like that. The numbers have to be the lowest ratio. But the crisscross method is great most of the time. Any other questions? Let's do another one. Magnesium and oxygen. Again, the first thing is to write the formula with the charge. Magnesium's in group 2, plus 2 charge. Oxygen has a minus 2 charge. So if we just crisscross without thinking about it, we end up with Mg2O2. Well, that's 2 to 2. That ratio could be reduced. And so the correct answer is, I forgot to enter drawing mode again, is down here, is MgO. Because 2 to 2 is like a fraction, right? That's the same as 1 to 1. The idea is that each compound has one formula, one molecular formula. And so we can't have MgO and Mg2O2 and Mg163O163. We'd have an infinite number of formulas. So we want the lowest ratio for ionic compounds. So the way I would approach this one, instead of just crisscrossing, I would first look at these numbers. Plus 2, minus 2, and I'd say, oh, that's nice. I'll just push these guys together. One of each, done. Any questions? If the charges are the same, push them together. You just need one of each. If the charges are not the same, then the crisscross thing is probably the best thing to do. There's another example. Write a formula for the compound that forms from calcium and bromine. So what kind of an ion does calcium form? Got to look at the periodic table. What group is it in? It's in group 2, so it forms a 2+ ion. Calcium is a metal. It forms a positive cation. How about bromine? What charge will the bromine ion have? -1. Those are based on location in the periodic table. This is an important skill. Now we have to figure out how to put those two together. So the crisscross method says we're going to take this 2, and that's going to be the subscript for the bromine, and this unwritten 1 comes down and is an unwritten 1 for the subscript on the calcium. Remember, chemists have a thing about the number 1. So CaBr2. Or if we're doing the picture method, calcium and bromide. And we just keep a running total down here. Here we've got +2 and -1. Those are not balanced. We need more of the negative ones. So let's put another one of these in. Now we've got 2 negative ones, that's -2. Oh, great, we're done. There's 1 calcium and 2 bromines. So CaBr2. Any questions?